5 days ago, the sky over Spain did something it hadn't done in 27 years. And then it did something no one alive had ever seen. On August 12, 2026, the moon slid in front of the sun and dragged a shadow across Europe for the first time since 1999. Millions of people stood in fields, on rooftops, and on mountain ridges from Iceland to the Mediterranean coast, waiting for 2 minutes of darkness. They expected the classic image, a black disk, ringed by a ghostly silver-white crown of light. That's not what they got. When totality hit northern Spain, the corona, the sun's outer atmosphere, normally the color of polished platinum, glowed gold. Not slightly warm, not tinted. Gold, like the sky had been dipped in honey. Photographers checked their filters. Veteran eclipse chasers, people who had crossed oceans for a dozen totalities, said they'd never seen anything like it. This is the story of why the 2026 eclipse turned gold, and why the explanation is even stranger than the picture. First, let's set the stage. Because this eclipse was unusual before it even started. A total solar eclipse isn't rare in the cosmic sense. Somewhere on Earth, one happens roughly every 18 months. What's rare is one happening where people actually live. The moon's shadow is narrow, a ribbon usually less than 200 kilometers wide, and most of our planet is ocean, ice, and empty, land. So the shadow spends most of its time darkening water and wilderness, where nobody is watching. On August 12th, the ribbon got lucky. It touched down near the top of the world, over Siberia, then swept across eastern Greenland, clipped the west coast of Iceland, crossed the open Atlantic, and made landfall in northern Spain, the first path of totality across mainland Europe in 27 years. Maximum darkness, 2 minutes and 18 seconds. And here's the detail that made astronomers circle this date years in advance. The eclipse landed on the exact peak of the Perseid meteor shower. During those 2 minutes of artificial night, with the sky suddenly dark enough for stars, some observers caught shooting stars streaking past a black sun. A meteor shower, during daytime, behind an eclipse. That combination may not repeat in our lifetimes, but the timing had one more trick built into it. And this is where the gold comes from. In Spain, totality didn't arrive at noon, with the sun high overhead. It arrived in the evening, barely above the western horizon, minutes before sunset. And that changes everything about the light. Just think about why sunsets are red in the first place. When the sun is overhead, its light punches through the atmosphere almost vertically, a short trip through the air. But when the sun sits on the horizon, that same light comes in at a shallow angle and has to plow through hundreds of kilometers of thick, dusty, low-altitude air. Air molecules scatter blue light far more than red. It's called Rayleigh scattering, and it's the same physics that makes the sky blue. On a long grazing path through the atmosphere, the blues and violets get scattered away completely. What survives the journey is the long wavelength light, orange, red, and gold. Now here's the key. The corona is sunlight too. It's the sun's outer atmosphere, a halo of plasma glowing at over 1,000,000 degrees, visible only when the moon blocks the blinding surface. Normally we see totality with the sun high in the sky, so the corona's light reaches us intact, pale, white, silvery. But in Spain, the corona's light had to make the same grazing, horizon-skimming trip through the atmosphere as any sunset. The atmosphere filtered the corona itself. That alone would have tinted it warm. But 2026 had a second filter waiting. That week, Spain was fighting one of the worst wildfire seasons in its history. Smoke from forest fires hung in the air across the Iberian Peninsula, a haze of fine particles drifting through exactly the layer of atmosphere the eclipse light had to cross. Smoke particles are bigger than air molecules, and they scatter away even more of the remaining short wavelengths. The blue was already gone. The smoke deepened the cut, stripping the light down to its warmest core. Horizon physics plus wildfire smoke. 2 filters, stacked. The result, captured in a WMLDA, now famous image from Benavente, Spain, and featured by NASA as its astronomy picture of the day. A corona the color of molten gold, unlike anything in the modern photographic record. And one detail in that image made scientists smile. Hovering off the sun's left edge was a prominence, a loop of hydrogen plasma arcing off the surface. Glowing hydrogen emits light at very specific wavelengths, dominated by a deep red-pink line called hydrogen alpha. That light is already red, so the atmosphere's blue removal barely touched it. In one frame, a gold corona sculpted by Earth's atmosphere, and a pink flame reminding us what the sun looks like without the filter. The physics of two worlds in a single photograph. The eclipse didn't just produce great science, it produced obsession. In the days since, the internet has been flooded with images from the path. The one everyone is talking about came from the middle of the Atlantic, a photographer who spent months planning with the captain of a cruise ship, plotting a course to park the vessel in the ideal spot on the centerline, far from any coastline haze. When the shadow arrived, the ship was exactly where it needed to be, and the shot became the most celebrated eclipse image of the year. Tens of thousands of people have shared it, not because the gear was exotic, but because the effort was. The lesson every eclipse chaser knows: the sky rewards preparation. Others climbed. One of the most striking sequences came from 1,600 meters up a Spanish mountainside, above the smoke layer, where the corona ran silver-white even as valleys below saw gold. Two people, a few kilometers apart, watched two different eclipses. That's how thin the filter was, and how local. So what happens now? If you missed August 12th, you are closer to the front of the line than you think, because we are living at the start of a remarkable cluster of eclipses. In less than a year, on August 2nd, 2027, the moon's shadow crosses southern Spain, North Africa, and the Middle East, and over Egypt. Totality will last more than 6 minutes. That's not a typo. 6 minutes, nearly triple what Europe just got, and one of the longest totalities anyone alive will ever witness. Astronomers are already calling it the eclipse of the century. And the 2026 golden eclipse taught us something to bring to it. Totality is not one fixed spectacle. It's a collaboration between three bodies: the sun providing the light, the moon providing the shadow, and Earth's own restless atmosphere providing the final edit. Change the sun's height, the air, the smoke, the altitude, and the eclipse changes with you. No two totalities are the same. That's why people chase them for a lifetime. 27 years. Europe waited for 2 minutes of darkness. What it got instead was something rarer. Proof that even the most predictable event in astronomy, an alignment we can compute to the second, centuries in advance, can still surprise everyone watching. The next shadow is already on the calendar. August 2nd, 2027. 6 minutes of darkness over the pyramids. The question is, where will you be standing? If this is the kind of story you don't want to miss, subscribe, because we'll be covering the road to the 2027 eclipse of the century, and the sky has a lot more surprises on the schedule.